Alright, now deal it up me now on the computer. Yeah. So alright, we're going to continue where we left off from Sunday. In which we stopped at what 2012. So we're going to continue from 2013, question 2. No, with question past paper. This is what May 2013, question 2. Well, all right. So this is factorize completely 2x. Factorize completely 2x cubed. Factorize completely 2x cubed minus 8x. This was the first question at question 2 for the 2013 May exam. So this is a factorization by distributive law question. So when you're factorizing, basically what you're doing, you're pulling out what is common within a pair. So 2x cubed minus 8x, we can expand this using multiplication by saying that 2 times x times x times x. So 2 times x times x times x will give you 2x cubed minus 8 is 2 times 2 times 2 times x. So 2 times 2, which is 4, 4 times 2, which is 8, times x will give you 8x. Now, what we're going to do, we're going to scan both sides of this minus sign to see what is common. So if you realize 2 is common on both sides, scan it again to see we don't have any more 2's that are common on both sides. So look, you see x. So what you'd realize is that 2x is common on both sides. So I'd put 2x, open a bracket. What's left is x times x. So what is left is what we did not circle. So x times x will give us x squared minus 2 times 2 would give us 4. Now, usually we would look at the question and say, oh, the question is finished. But looking inside the bracket, you'd realize we have x squared minus 4, in which this is the difference of 2 squares. So what we would do is we would look at the difference of 2 squares and say, okay, what did we square to get x squared? We square x. What did we square to get 4? We would square 2. What we would do, put back our minus sign, put a bracket here, put the 2x outside. So it's solving the difference of 2 square. What you would do is to just open 2 brackets. So it seems like I'm writing down too low. So let me erase this, write a bit higher. So what we would have is 2x bracket x squared minus 4. So that's this is the difference of 2 squared. So we would locate or find what we would square to get x squared, what we would square to get 4, in which, so we would rewrite the 2x, open 2 brackets, 100 plus, 100 minus, and what we're going to write inside those 2 brackets is what we would have underneath the small brackets that I had before. So it seems like I'm skipping out a step. So let me just rewrite all the steps. So what I would have is 2x bracket, in small bracket. So I would square x to get x squared. I would square 2 to get 4. So to conclude this question, I'd write 2x, open 2 brackets, 100 plus, 100 minus, and put what we have underneath the small brackets on either side. So we'd have x plus 2 and x minus 2. So that is how we would solve the difference of 2 square section of the question and rewrite the 2x outside of it. So for the persons who are here, remember you can always text and let me know if you understand what I'm saying. Or do you want to text in the WhatsApp group, or you want to text comment on the YouTube channel? So that is how you'd solve the first question. So what I'm going to do, I'm going to run over a few questions that it's not on the past paper, but it involves factorizing difference of 2 squares. So let's say we had z squared minus 16. Now, factorizing z squared minus 16 with first, well, the topic is difference of 2 squared, but to really identify and figure out that it is actually the difference of 2 squares, you'd have to pay attention to the numbers and make sure that they are separated by a minus sign. So z squared, z is a square number, or you could say a square variable. 16 is a square number. You know that when you square 4, we would get 16. So we would open 2 smaller brackets, and we're going to write down what we square to get the numbers at the top. So we would square z to get z squared. We would square 4 to get 16. We would open 2 smaller brackets or 2 other brackets So we'll put plus in one bracket and we'll put minus in the other. And we'll put what we have underneath the small brackets on either side. So we'll have z minus 4 and z plus 4. And that would give us our answer. Now, expanding the answer, we are going to end up back with a question. So what we would do, we would multiply each term in this bracket by each term in this bracket. Or we could say we would multiply each term in this bracket by the terms in this bracket. So we're going to multiply z times z, that would give us z squared. Z times minus 4 would give us minus 4z. 4 times z would give us positive 4z. And 4 times minus 4 would give us minus 16. So what we have in the middle here are the like terms. And if you realize with the like terms, they're the same, but they're of opposite signs. So they would cancel each other. So we would end up back with the question that we had. Z squared minus 16. So this would be the answer for factorizing z squared minus 16. What I did here was to just prove that the answer would be indeed correct. So let me do another one. So I'm just running over the difference of two squares. So with this one, let's say we had 100 minus y squared. So 100 is 100 a square number. Yes, we would square 10 to get 100 minus y. We would square y to get y squared. So we're going to open two brackets. 100 plus, 100 minus. Whatever we have underneath each small bracket, we're going to put on either side. So we would have 10 plus y and 10 minus y. So if you realize all they're doing basically the same thing over and over, just finding the square root of the numbers. So 100, to get 100, we would square 10. To get y squared, we would square y. And then after that, we just write two brackets, 100 plus, 100 minus. And that would conclude the answer. Now the question that we did was a little bit trickier than this one. So I'm just going to run through probably one or two more simple questions like this. Then I did do another one like the one that was on the past paper. So let's say we had a squared minus b squared, and let's say you're supposed to factorize it. The first thing, make sure that it is a difference of 2 squared. Make sure that both numbers are square numbers and it's separated by the difference sign. So difference means to subtract. So what you would do is what we would square to get a squared, what we would square to get b squared. So we would square a to get a squared. We would square b to get b squared. Then we would open two brackets, 100 plus, 100 minus, and whatever we have underneath the small brackets, we'll put them on either side. So it's a plus b, a minus b. That would be the answer. I'm going to do one more similar to this, then another one, or probably the two like the one that we did on the past paper. So it's a difference of two square numbers. So let's say we had 25 minus 9x squared. So are these square numbers? So let's see, 25. What we would square? What we would square to get 25? We would square 5 to get 25. Minus 9 a squared number. Yes. We would square 3 to get 9. Is x squared a square number? Yes. We would square x. 3x to get 9x squared. Then we would open two brackets, 100 plus, 100 minus, whatever we have underneath the small brackets, put them on either side. So it's the 5 plus 3x, 5 minus 3x. So that is how you factorize questions that are of the difference of two square format. So I'm going to do two that are, I'm going to do two that resembles the one that was on the past paper. So let's say we had, for example, 2x squared minus 8. So 2x squared minus 8. Look at the question carefully. Is it the difference of 2 squared? That's the first question. Because it's separated by the minus sign. We have x squared here. We have an 8 here. Is 8 a square number? No. So the first thing we're going to have to do, we're going to have to apply factorization by distributive law first. So what I'm going to do, I'm going to write 2 times x, because 2 times x is going to give us 2x squared, minus 8. 8 is 2 times 2 times 2. Then we scan both sides of the minus sign, both sides, this side and that side, and we realize that 2 is common on both sides. So look again, anything is common? No. So we'll write 2, open bracket, what's left? X squared minus 2 times 2, 4. Now, x squared minus 4 is the difference of 2 squares. So what you would do, you would look to see, you write the 2, open a square bracket here. Then, what do we square to get x squared? We would square x. Minus, what would we square to get 4? We would square 2. Close our square bracket. Now, we would open 2 brackets, rewrite the 2, and I would open 2 brackets, one with plus, one with minus. Whatever we have on either sides, what we have underneath the small brackets, we'll put them on either side. So it would be x plus 2 and x minus 2. So that would be our solution for that question. So it's similar to the one that was on the past paper just now. So I'm going to work one more similar to this one. And that would be it. Let's go back to the past paper. Now the thing is, for the persons who want to write off the questions, what you could do is could press back and like on the and then they don't want to tell me say almost curfew. Come on for the road. Alright, you can just press back on the thing that you're watching and you will be able to write this off. Or it's also going to repeat what how I just worked out the question. So I'm going to do another question similar to this one. Then go back to the past paper question. So let's say we had 3a cube minus let's say 9a. Or let's say 27a, because that's not going to work. So 27a. So we need to factorize this. So you go in the exam, see a question like this: 3a cube minus 27a. Now, looking at this, you cannot see the difference of 2 squares. So what you would have to do, you'd have to expand everything first. So you would have 3 times a times a times a minus 27 is 3 times 3 times 3 times the a. Then we look on both sides of this minus sign to see what is common. Realize that 3 is common. What else is common? A is also common. So we'd write 3a, open bracket, what's left? A times a, which is a squared, minus 3 times 3, which is 9. So inside this bracket, you'd realize that we have the difference of 2 squares. Now, with the difference of 2 squared, we figure out what we square to get a squared, which is a. What do we square to get 9? That is 3. Then I'd put a square bracket around this and rewrite our 3a. Then to conclude our question, or to finalize the question, I would rewrite the 3a, then open 2 brackets, one with plus, one with minus. Whatever we have underneath the small brackets here, we put them on either side. So it would be a plus 3, a minus 3. That would conclude that question. So I hope that helped, because we did that, I think it was last year when we were on algebra. So I'm going to go back to the question 2, 2013. So So with the underneath factorization, we're still at A. So they say factorize completely. So they had 2x cubed minus 8x. I'm just going to rework this one. So what we're going to do, we're going to have to factorize by distributive law first. Looking at this, you would not necessarily see that it's the difference of 2 squared. So we're going to expand. So we're going to have 2 times x times x times x minus 2 times 2 times 2 times x. Scan both sides of the minus sign to see what is common. X is 2 is common. X is also common. So we would write 2x, open bracket, what's left would be x squared minus 4. That's 2 times 2 is 4. You would rewrite the 2x, open a square bracket. You would look to see or figure out what we would square to actually get x squared and 4. So we square x to get x squared, minus we square 2 to get 4. Then I'm just going to rewrite my 2x, then open 2 brackets, 100 plus, 100 minus, whatever we have underneath the small brackets, put them on either side. So it would be x plus 2 and x minus 2. And that would conclude the answer. So for the second question, So for the second question, it says that we're supposed to factorize. So I'm going to remove this. It says that we're supposed to factorize 3x squared minus 5x minus 2. So that's a quadratic trinomial question. So to factorize this, we use the AC method. Remember that this quadratic is written in the form of ax squared plus bx plus c. That's the general form for a quadratic expression. So using the AC method, in which we're going to multiply a times c. In this case, we're going to multiply 3 times negative 2, in which we're going to get negative 6. So after getting the negative 6, we need to find two numbers. We need to find two factors. When we multiply those two factors, we should get back the negative 6 that is there. And when we add those two factors, we should get the b value, which is negative 5. So b is negative 5. So I'm going to repeat that. So after multiplying 3 times negative 2, because c is negative 2, I'm going to get negative 6. Then after getting the negative 6, we need to find two numbers or two factors. When we multiply those two factors, we should get negative 6. When we add them, we should get negative 5. So not all the time the factors are going to be on the board, but sometimes they are, sometimes they are not. Because we could try 3 and negative 2. 3 times negative 2 will indeed give us negative 6, but if we should add them, 3 plus minus 2, it would give us positive 1. We don't have that. That means we have to resort to other factors. So we have negative 6 times 1. Now let's see, negative 6 times 1 will indeed give us the negative 6. Negative 6 plus 1 will give us negative 5. So if you realize negative 6 and 1, those two factors fit the criteria for the two for the negative 6 and the negative 5 right here. So what I'm going to do, I'm going to replace the middle term with the two factors. So what I'm going to have is 3x squared minus 6x plus 1x minus 2. And you don't have to put the 1 because 1 times x is just x. But I just put it there so that it doesn't confuse students. So because of this 1 here. So next step, we would factorize by grouping them into pairs. So the first pair, look to see what is common. If you cannot see what is common from here, you just have to do what we were doing from before with factorization by distributive law, by expanding this, expanding that. So when you expand it, you realize that 3x is common on both sides. And inside the bracket, you would have x minus 2 that would be left. So 3x times x gives me back 3x squared. 3x times minus 2 would give me the negative 6x. So remember, when factorizing quadratic trinomials, anything that is in this bracket here should be in the bracket on this side, x minus 2. We're going to pay attention to the sign that is in the bracket and the one that separates the second pair. So the signs did not change, so I'm going to put a plus sign out here. Now, if you look at the question, or look at the expression right here, usually we would look to see what is common, but nothing is really common there. So we have to put a number here that would not change anything after we had expand this bracket. So the only number that we could put outside this bracket is 1, because 1 will not change anything inside the bracket. 1 times x would give us the 1x, and 1 times minus 2 would give us the minus 2. So what I'm going to do again, I'm going to factorize, because realize x minus 2 is common. So x minus 2, write that, and what is left outside the brackets, put that in a bracket. So it would be 3x plus 1. That is how we would factorize the quadratic trinomial. So as I said, we factorize here again, but could just say that you have x minus 2 twice, so you write it down once, and whatever you have outside the brackets, you put those in a bracket by themselves. So that would conclude the quadratic trinomial question. So looking at the other question. So looking at the other question, question 2b. So with question 2b, they say make C the subject of the formula. The formula f is equal to 9 over 5 C plus 32. So they say make C the subject of the formula. Now to make C the subject of the formula, we have to basically get rid of everything from around C, starting with the simplest term that we can move. So right now we have 9 over 5 multiplied by C plus 32. So what I'm going to do, I'm going to remove the 32 first, because the 9 over 5, it does not affect the 32, only the C. So once we're adding here, it's easy adding our minus. We could just simply bring it over the equal sign. So I'm going to have f minus 32 equals 9 over 5c. So this 32 is positive. When it goes over the equal sign, it's going to be negative. So bringing over the positive 32 is the same thing as subtracting 32 on both sides. You'd end up with f minus 32 equals to 9 over 5c. Now we need to remove the 9 over 5. Now we have two ways in which we could remove the 9 over 5. We could either multiply both sides by 5 first. So this 5 would cancel that 5. So we would have 5 bracket f minus 32 equals to 9c. And then afterwards, we could divide both sides by 9. So c would be the subject. The subject must be on the left-hand side. C, 9 cancel 9. So c should be on the left-hand side. So what you would have is c being equal to 5 over 9 f minus 32. So that would be the answer. So as I said before, you had two ways in which you could remove the 9 over 5. You could have also multiplied both sides by the multiplicative inverse of 9 over 5. So the multiplicative inverse of 9 over 5 would be 5 over 9. So what I'm going to do, I'm going to just erase this and do it that way. So remember, you could always press back and re-watch what I just did with the question. So let's remove this. So we would have 9 over 5 C. So as I said before, what we could have done is multiply both sides by the multiplicative inverse of 9 over 5. Now the multiplicative inverse of 9 over 5 is 5 over 9. So we could multiply both sides by 5 over 9. So 9 would cancel 9, 5 would cancel 5. So if you realize what we would have is C being equal to 5 over 9 times F minus 32. And if you realize we end up back with the same answer. The same answer, and it's even a bit shorter. So that is how you'd make C the subject. So C must always be on the left hand side. So C is equal to 9 over 5 bracket F minus 32. What you could have done also is to use distributive law to expand that bracket. And you'd get back the same answer. So whether you expand it or not, it's the same thing. So that is how you'd make C the subject. Alright, so for the follow-up question, it's a given that F. It's a given that F. So I'm going to erase this. So C is now the subject. So C is equal to 9 over 5 F minus 32. So they said that given that F is equal to 113, they said given that F is equal to 113, calculate the value of C. So they want to find C when F is equal to 113. So that's basic substitution. So I'm going to have C is equal to 9 over 5, open bracket, 113 minus 32. So what we could do is to solve inside the brackets first. So we would have C equal to 9 over 5 times, because bracket means to multiply. Now 113 minus 32 is going to give us 81. So why do I feel like I've made a mistake? Yeah, I did. I did make a mistake. The answer should have been 5 over 9 here, not 9 over 5. It seems like I rewrite the 9 over 5 instead of rewrite 5 over 9. So this should be 5 over 9. This should be 5 over 9. So sorry about that, students. So could we use the quadratic equation? That's for the comment. Could we use the quadratic equation for which question? The one that we solved before, the one that we factorized before? Alright, so the person who names vibe with Taj, text me on the, alright, so yeah. I think it will be easier if you text me on the WhatsApp group, if you're in the WhatsApp group. Now the thing is, with the quadratic equation, or the quadratic formula, because I'm assuming that you're referring to the quadratic formula. The quadratic formula is used to solve the quadratic function. Solve it, not to factorize it. So if you had, like, for example, I don't really remember the question, I'd have to look back. So let's say we had 3x squared. I think it was minus 5x minus 2. So if this was equal to 0, then we could use the quadratic formula to solve it, as in x equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Yeah, we could use the quadratic formula to solve this quadratic equation. The quadratic formula is not used to factorize the quadratic equation, but it is used to solve for x, as in to determine the values of x. So we could use it if the question was equal to 0. Does that answer your question, miss? Yeah, man, it would be 5 over 9, not 9 over 5. Yeah, I made a mistake there, so sorry about that. And the answer would be 45. Well, I'm not sure if it would be 45, but we could check and see. So we would say 9 into itself 1, 9 into 81 goes 9, and 9 times 5, yeah. So it would be equal to 45. So the answer would be 45 indeed. Yes, so sorry about the 9 over 5. Didn't even realize that I had rewritten the 9 over 5 instead of 5 over 9. Sorry about that. I remember if you have any other questions, you can either WhatsApp, text in the WhatsApp group, or comment down below. I'll try and read the comments as I see them. So we can move on to the next question now. So it's a worded question. CXC loves worded questions. So with the worded question, it says 500 tickets were sold for a concert. Of these, X tickets were sold at $6 each, and the remainder at $10 each. Write an expression in terms of X for the number of tickets sold at $10 each. That's the first question. That's A. And for B, all right, so we're going to solve them piece by piece, basically. So I'm going to reread the question. It says 500 tickets were sold for a concert. All right, so we have 500 tickets. 500 tickets were sold for a concert. They said of these, meaning of the 500, X were sold at $6 each. So of these, X of these tickets, so X of the 500, X were sold at so X were sold at $5 each. So X of the tickets were sold for $5 each. What other information should we get from this? And they said the remainder. All right, so the remainder at $10 each. So yeah, so that's the most important part of the question. They said write an expression in terms of X for the number of tickets sold at $10 each. All right, so 1 mark. So it's nothing too complicated. It's very simple. So they want us to write an expression for the number of tickets sold at $10 each. Remember, $10 each was the remainder. No, remainder. What are they referring to? What are they talking about? So probably some persons read this and don't even understand what they're asking. No, they said 500 tickets were sold for a concert. X were sold at $10 each. Now, X of these tickets, X, where did the X come from? The X came from the 500. The X is representing an unknown variable, an unknown number. So the X is representing an unknown numeral, an unknown number. So to determine the remainder, we would have to actually subtract the X amount from the 500. So 500 minus X would be the remainder. So this would be the answer. So this amount of tickets were sold at $10 each. Because let's look at it. Let's say X represent a number, for example. Let's say X represent 50. I'm just assigning a number to X. So let's say X was 50. So 50 tickets were sold at $5 each, and the remainder at $10 each. How would we determine the remainder? We would have to subtract the 50 from the 500. So we would have 500 minus 50. But remember, they did not give us the 50. I assigned it a value for it to be or look simpler. So, well, if it was 50, the remainder would be 450, but it's not 450 because I said I assigned a value to it. So 500 minus X would be the answer. That would be the expression. So that's the answer for the first question. So I hope everybody understood that. So don't ask questions. So this is the answer for A. So X tickets were 500 minus X were sold at $10 each. All right, so they said for B, the total amount of money collected for the sale of 500 tickets. So they want us to write an expression in terms of X for the total amount of money collected for the sale of the 500 tickets. So the total amount of money. So to determine the total amount of money collected for the sale, you have to remember that um, five X tickets were sold at $5 each. So to determine the total amount of money collected for the sale of the X tickets, I would have to multiply 5 times X. Now, probably some students are finding that difficult to understand. So let's look at something a bit simpler. Now, let's say we had some sweets, or let's say we had some marbles, for example. Let's say we had some marbles. We had about 20 marbles, and I'm going to say that okay, 15 of these marbles, 15 of these marbles were sold at $2 each. 15 of these marbles were sold at $2 each. To determine the total amount of money collected for the sale of the 15 marbles, I would have to multiply 2 times 15, in which that would give us $30. So when we sell 15 marbles, we got $30. Remember, $2 each. So it's 2 times 15 would give us $30. And the remainder, let's say the remainder was sold at the remainder was sold at $1 each. Sold at $1 each. Now with the $1 each, we know that we have how many marbles would we have left? We would have about so 20 minus 15, we would have 5 marbles left. So to determine the total amount of money collected for the sale of the 5 marbles, is multiply 5 times 1, in which that would give us $5. So the total amount of money collected for the sale of the 20 marbles would have to add the 30 and the 5. So that would give us $35. So we've collected $35 for the sale of the 20 marbles. So I'm going to apply this simple principle to the question that we are solving here. So I'm just going to remove this, clean up the board a bit, and go back to the question. So they said that X sold at $5 each. So we know that that is 5X dollars. So 5 times X, that would give us 5X plus, remember the remainder was sold at $10 each. So that means I'm going to have to multiply 10 times the remainder to determine the total sum of money here. So it would be 10 times 500 minus X. So that would be our expression for the total sum of money collected for the sale of the 500 tickets. So you could leave it as this, or you could simplify it, because this is an expression. So we could simplify the expression. So an arrow there, not an equal sign, because this is an expression. So we have 5X dollars. So 5X dollar plus 10 times 500, that is going to give us $5,000 minus 10 times X, that is going to be minus 10X dollars. And we could calculate terms. So we could have 5X minus 10X plus $5,000. And remember, all of these are in terms of money. So that's why I'm putting back the dollar sign in terms of dollars. So what we would have for finalizing our expression, as I said, you could leave that as the answer. That could be that is the answer, but I'm just simplifying my work. So I would have minus 5X minus 5X. Remember the dollar sign plus $5,000. So that would be simplified version of the expression. You could also write it the other way around. It doesn't really matter. You could write it as 5,000 minus 5x. You could write it as that. So as I said, this is our answer, or you could simplify it to get this. Okay, what else did they say about the question now? And that was for 1 mark. So you couldn't, you didn't have to simplify it. You could just write this as the answer, and that would conclude everything. The second part of the question now. which is for 3 marks. They said the sum of $4,108 was collected for the sale of the 500 tickets. Calculate the number of tickets sold at $6 each. So previously wasn't it 5? So it was 6. Oh, so we just replace this with 6 because it's 6. Because I don't need glasses now. So this should be 6. So if that is 6, this should be 4. Minus 4. Minus 4. Because 6 minus 10 is minus 4. So minus 4 to change that. Alright. So not even know why maybe I misread everything tonight. Alright. So the follow-up question, it says that the sum of $4,108 was collected for the sale of the 500 tickets. Calculate the number of tickets sold at $6 each. So they want us to calculate the value of X. They want us to calculate the value of X. Now, they gave us one important information in that statement there. They told us that the total sum of money for the total amount of money collected for the 500 ticket was $4,108. $4,108. Now, what can we do with this $4,108? This $4,108 represents the total amount of money collected for the sale of the 500 tickets. And the question that we did before that had 5,000 minus 4x, this also represents the total sum of money collected for the sale of the 500 tickets. So if this represents the total sum of money collected for the sale of the 500 tickets, and this also represents the total amount of money collected for the sale of the 500 tickets, what we could actually do, if both of them represent the same thing, so we could just equate them. We could just let them equal to each other. So I'm going to remove here. Hope that makes sense. It seems like some persons are having internet difficulties. So let me try something like this. So after equating both things, then we can solve for x. Now this becomes a linear equation. So it's very so to solve the linear equation, just collect like terms. You would just collect like terms and then simplify the linear equation. Right, so let me just do this. CNRP. So to solve the linear equation, just collect like terms. So minus 4x, we could just remove the dollar sign. Minus 4x equals to 4,108 minus 5,000. Then we'll have minus 4x equals to, so if we add this thing, not picking up. So if we should so add 900 to that, we'll get 5,000. So 900 minus would give us 908 would give us 892 divided by negative 4. This negative divided by negative 4. What my subtraction equation? Minus 5,092 divided by negative 4 is going to give us 223. So 223 tickets. 223 tickets were sold at $6 each. And that would conclude our answer.